Hi everyone. It's Tuesday, April 28th. We are on lesson 9. Here we go. Our target for today is I can solve real-world problems involving area of figures with fractional side lengths using visual models and or equations. So basically we are going to do what we've been doing all of these lessons, but through word problems. And we are going to sketch or draw our rectangles and label to make it easier for us to solve these problems. Okay? So make sure you have a pencil and paper or your notebook so you're ready to begin. Vocabulary, when they say fractional side lengths, those are just the measurements for each side. And our fluency for today, we're going to recite the multiples of 7, clicking our fingers. Click 2 times for each answer, and you can hear me clicking, so get ready. Here we go. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. Okay. Okay. So let's review before we start our lesson today. We will review on how to find the area of 5 and 4/6 times 4 and 3/5. Think about this. What would be the first thing that you would do to solve this problem? Remember, you have 2 strategies that you can use, the break apart method or changing the mixed number to an improper fraction and then multiplying method. Totally whatever good for you, what you think helps you solve this problem easiest. Whatever works for you. You know I always like to give you a couple ways on how to solve problems to make it easier for you. Okay, so let's look at this. I chose to do the break apart method because these were bigger mixed numbers. Totally up to you. Okay, so to review a little bit, I did make our rectangle. I split up my whole number and my fraction. My whole number and my fraction. Now I'm going to multiply. 5 times 4 is 20. You can see that in the red. My products are in red. 5 times 3/5 equals 3. You saw how I got that. 15 over 5 equals 3. 4 over 6 times 4 is 16 over 6, which equals 2 and 4 over 6. And 4/6 times 3 over 5 gives you 4 over 6 times 3 over 5 equals 12 over 30. So now I have my 4 products. I'm going to add them all together. Remembering we can't add unless our denominators are all the same. So my whole numbers stay their whole numbers. And I'm making my 2 and 4/6 and my 12 over 30. That's going to equal all of those. 1, 2, 3, 4 are going to equal 25 and 32 over 30. Don't forget I made my 4 over 6 into 20 over 30. 6 times 5 is 30. 4 times 5 is 20. And then I said 20 plus the 12 gave me 32. So now I have 25 and 32 over 30. So my whole number stays my whole number, 25, plus, this is an improper fraction, 32 over 30, so I had to divide it, and I got 1 and 2 over 30. Now I have 25 plus 1 and 1 over 15, which equals 25 plus 21 is 26, and I reduced 2 over 30 to 1 and 1 over 15. If you choose to do the other way, that is also fine. Which brings me to that other way. Another way to find this is by changing the mixed numbers to improper fractions, then multiplying. So let's change 5 and 4, 6. We change that into 34 over 6. 5 times 6 plus 4 is 34 over the denominator you started with, which was 6. 34 over 6. Let's change 4 and 3/5 into an improper fraction now. 4 times 5 plus 3 is 23 over 5. Okay, so then I multiply across, multiply across. 34 times 23 equals 782 over 6 times 5, which is 30. When you go ahead and divide that out, you will get 26 and 2 over 30. And then I reduced 2 over 30 and got 26 and 1 over 15. Same answer you got with the other method that you could use. Totally up to you on which one that you would like to use. Okay, so to start our lesson today, let's read this problem aloud and I will show you how we will solve this. Keeping in mind that our target is using these past lessons that we've been learning and the two specific methods that I just went over to make sketches, to help you also label them, and to find out how to get an answer. Okay, so this one, George decided to paint a wall with 2 windows. Both windows are 3.5 and 4.5 feet rectangles. Okay, so this one is 3.5 times 4.5. This is 3.5 times 4.5. Find how much paint is needed to cover this one and this one. Think about this. This one is a multi-step problem. So look at this picture here. Okay, we want to know to paint the walls, but we also have windows here. So, we've got 12 and 7/8 times 8 for an area of this whole entire wall. That's including what's inside of it, everything inside. But then we have these 2 windows, 3.5 and 4.5. So we would have to, well, let's go through this because this is a multi-step problem. We're going to go step by step. Here we go. Step 1. First, we're going to find the area of the 2 windows. They said that the area of each one was 3.5 times 4.5, which equals, if we change this, that would be 7 over 2. And if we change 4.5, that would be 9 over 2, which equals 63 over 4. Okay, so 63 over 4. So we need to take that answer and multiply it by 2 because there's 2 windows, 2 rectangles. This is one window, and 63 over 4 was for one window. And 63 over 4 was for that window. All right, so when we did that, we've got 31.5 for my answer. 63 and 1/4 times 2 is 126 over 4. And we got 31.5. So let's go to our step 2. Next, we will find the area of the wall. The whole wall will be the whole length and the width. So now we got 8 times 12 and 7/8. So 12 times 8 plus 7 is 103 over 8, and then we've got 8 over 1. Multiply across, we got 824 over 8, and that gave us an answer of 103. That was step 2. So we got, the first step was, let's get the area of the windows. Now we're getting the area of the whole entire wall. Now, step 3, we're going to take our answer from the beginning, from the 2 windows, and we're going to subtract it from the total area of the whole entire wall. And when we subtract the 2, we get 71.5 feet squared. And you see how I subtracted that. I cannot take a half from nothing, so I had to go over and make 103, 102, and make a fraction here looking at the denominator, which would make 2 over 2 on the top. 2 at the bottom here, so come over here. I took 1 whole from here. What is 1 whole in a fraction? If I look at this denominator and it's a 2, a whole number would, in a fraction, would be 2 over 2. Now I take a half from 2 over 2 and get a half, and then I subtract the rest, 71.5 feet squared. Okay. We could do the same problem by doing another strategy using the distributive property. You could draw your sketch and break it apart. Okay, and they do the same exact thing that we just did. Here's the area of the wall. Okay, they broke apart 12 and 7/8. 12, the whole number over here, and 7/8 over there. Okay, so 8 times 12 was 96, and 8 and 7/8, 8 times 7/8 became 7. Okay. Now the next part, area of the windows. Remember, there's 2 of them. So now we went ahead and did that, and we got what they did for this. They separated the 3.5 and the 4.5. Okay. And here are all of our products. 3 times 4 is 12. A half times 4 is 2. 3 times a half is 3 over 2. A half times a half is 1/4. When we added all the products up, we got 15 and 3 over 4. And 15 and 3 over 4 times 2, because there were 2 windows, don't forget, we got 31.5 feet squared. You notice that it said 6 over 4 first. We had to divide that and then add our answer to the 30. So that brings us to 31.5. Okay, so then we took the total that we got, 103, and subtracted the 31.5, and we got our answer of 71.5 feet squared. They wanted to know what's the area that needs to be painted if we took the windows out. The measurements of the windows we had to take out because we're not going to paint the windows. That's why we're subtracting the measurements of the windows, because we only want to paint the wall. Okay. So again, these are some really good examples. Please make sure you go back if you have questions. Okay, so Mr. Johnson needs to buy sod for his front lawn. If the lawn measures 63 2/3 by 45 1/6, how many square feet of sod will he need? What strategy would you use? Do you want to use the break apart, the distributive property, or changing your mixed numbers into improper fractions? Well, this one is showing us the break apart. So we said 36, here's my whole number, here's my fraction. 45 1/6, here's my whole number, here's my fraction. Multiplying them and getting our products. 45 times 36 is 1,620. 45 times 2/3 will be 30. You would have 45 times 2 over 3. You'd get 30, and you divided it. 1/6 times 36 is 6, and 1/6 times 2/3 is 2 over 18. Okay, when you add all your products together, you get 16 and 1,656 and 2 over 18. When you reduce that 2 over 18, it's 1 over 9. 2 divided by 2 is 1. 18 divided by 2 is 9. So that would be your answer for that one. Okay. So let's review our target. Make this a little smaller so that you guys could see the whole thing. There you go. Okay. I can solve real-world problems involving area of figures with fractional side lengths using visual models and or equations. Okay, so that definitely is a real-world problem because we talked about painting a wall with windows on it, and obviously we can do that in the real world. And the fractional side lengths, we drew pictures and we labeled our sides to give us a model. And when we used the other method of changing our mixed numbers into improper fractions, we wrote our equations out and we solved. Okay, so it's important to remember that when solving these problems that you have the different strategies to use. So use the best strategy for you. Okay, try your best. Remember to complete your homework. Not too many problems. Okay, alrighty. Don't forget, you can always email me if you need me. Have a great night and talk with you tomorrow. Miss you all so much.